friends, day 32 for solving problem of the day from GFG. Let's look at today's problem. Given n nodes of a tree and a list of edges, find the minimum number of nodes to be selected to light up all the edges of the tree. An edge is light up when one node at the end of the edge is selected. Okay, so let's look at this example to understand the problem. Okay, so we have given this tree. Suppose 1 is connected to 2 and 3, 2 is connected to 4, 3 is connected to 5 and 6. So what they're saying is, if you select this node, then this edge will be selected. That means if you select this node and this node will be selected. This is already selected, right, for the node 4. So this node is selected. Now if we select this node, this edge will be selected. If we select this node, this and this will be selected. This is already selected, so it will select only this and this. Now by this we select all the edges, right? So we need how many nodes to select? 1, 2, 3, 4. So that is one way. Now if we select suppose this node, then this and this will be selected. And if we select this node, this will be selected, because for 1, 3, 5, 3 and 3, 6, 3 is one of the node of this edge. So selecting 3 means selecting this edge. Okay, so in this way we can select all the edges by selecting 2 nodes. So 2 is the answer, as in this case the minimum number of nodes to select such that all the edges will be selected is 2. We have to select nodes, and by this we will select edges. Okay, so we have to select nodes. By this we will select edges, and we have to select all the edges, and for this how many nodes to be selected? Okay, so this is the question. Okay, now this is pretty simple question actually. The property is itself the solution. Don't need to worry about this. See, if we have these 2 nodes, n1 and n2, then I have to select only one of them, right? That will select this whole edge. So we have to select only one edge. We don't need to select 2 edges. That is the hint 1. Now the second hint is, consider this edge. This 1, 2, 4, 3, 5, 6, right? Consider this edge 2, 4. In this edge, which of them you will try to choose, 4 or 2? Obviously you will try to choose 2, because 2 is connected to 2 edges. Selecting 2 means selecting this edge and this edge also. Think for this edge, which one of them you will try to select? Obviously 3. Same for this edge also, you will try to select 3. Same for this edge also, you will try to select 3, right? So what I want to say is that here is a node. Suppose it is C and this is P. This is the child node, this is the parent node. You will select child node or parent node, which is more beneficial? Actually selecting parent node is more beneficial. Okay, because this is a parent node, it may connect to some other parent node. So selecting this node will select this edge and this edge also. Okay, and why this will work? Because we will start solving by post order, and by post order we will go from child to parent. We will solve the problem in this question by post order. So post order means actually going like the right side of the nodes. Here I am going the post order. Here I am going the post order. Here I am going the post order. So this is the post order actually. This, and this. Okay. Let me erase this thing. So 1, 2, 3, 4, 5, 6. So going like from here to here, here to here, and here to here in the traverse of like this. We will traverse like this. This is the uh, traversal Euler approach, and this is the post order when we go like this in our code. Okay. In our code, when we go like this post order, we will try to solve the problem. So going post order means actually going from child to parent, from child to parent. See, child to parent, again child to parent. So going from child to parent, we will see a child node here and a parent node here. So we will select the parent node. Why? Because it may be connected to some other parent node. So selecting this, we will select this edge as well as this edge. So selecting this is more beneficial. Okay. And if both are so we will select one of them is none of them is selected, right? Obviously, if C is selected, suppose we are going post order and we find that C is already selected, so we are not going to select any of them. So we will select them. This is the basic thing, right? So if we want to select a node, here is C, here is D, we will select a node if none of them is selected, because we are selecting a node in the purpose of selecting this edge, right? If one of them is selected, that means this edge is already selected, so we will not select that again. This is meaningless, right? So this is the approach. We will go by post order and we will just select the parent node. This will solve our problem. Now let's code. So it's a pretty simple graph problem. So create an array list first. Sorry, it will be capital N. Now I have told you this part, what I am doing right now, creating a graph. This is actually a graph problem, right? This is not a tree problem because we have given the edges, and the problem where edge is given is a graph problem. So this is the common thing which I am doing now, just computing the graph array list, array of array list. So you can check my previous videos. I will give the link in the this I button. Now here actually we have given the nodes in base 1, 1, 2, 3, 4, not 0, 1, 2, 3, 4, right? So we will utilize doing -1 to actually compute the whole problem as 0 base indexing. Okay, then the node numbers are 1, 2, 3, 4 like this, but we to use the original graph structure, we will do 1 minus 1, 2 minus 1, that will give me 0, 1, 2, 3, 4 like this, the node numbers. Okay, so that's why I am doing val1. So val1 is this, val0 is this. For the next term, val1 is this, val0 is this. So I am doing both -1. This will give me 0 base nodes. Now I will just call DFS, depth first search. This is my 0 current node minus 1, as there is no previous node for the root node. 0 is the root node, and I will pass this class array of array list. Before that I will create a visited array to mark which so for the edge there are two nodes. So if one of them is selected, that is visited of that node is true, I will not select any of them, because one node is selected, that means the edge is selected already. Okay, so let's give me here I am creating a boolean array, count variable. What I'm gonna do, just this is the DFS, basic DFS function. Okay, nothing to learn here. I'm just calling it. So this is the basic DFS function. Now as I am doing the solving the problem by post order, so post order means what? You will do something after the recursion call. So doing anything after a recursion call is post order. Doing something between two recursive call is called as in order, and doing something before all the recursion calls is called pre-order. So what we will do here, so if any of the two nodes are not visited yet, that is current is not visited and previous is also not visited, then I will select the parent node, that is select the parent node here. And also as I am starting from 0, so if my previous is -1, so I will not do anything, because visited -1 will be invalid, right? So for the root node there is no parent, that is what I am saying, previous not equal to 1. So I will select the previous as true, and I will do count plus plus, and I will return count. And I hope this is done. Yeah, let's run this. Okay, so we have some error, missing return statement. Okay, so we have to return this function's result. Okay, what the count plus plus will do, whenever I select a node, my count will be incremented, right? That is the thing. So doing this thing is actually happening in the post order, because it is happening after the recursion call. Okay, so actually we are starting from the child. So after all the callings, when it will get no child, then this part will be executed. That means actually it is starting from child. Okay, so let's dry run this once. Let's dry run this once. 5 6, right? So this is the calling BFS. This is going here. It will be not executed because there is no children for it, right? So val is the children's, and for the leaf node there is no children, so this part will not be executed, this part will be executed. So none of this and this are selected, so we will select this one, these two, then it will get back. Then for 2 4 is selected, so this part will be executed already. Now this part has to be executed. So for this part one of them is selected, right? So we will not select anyone, and also my count is became 1 for selecting 2. So after that for 2 the work is done, it will return 1 and go like this. Here I again approach at a leaf node, and here also only this part will be executed, not this. So here none of 3 and 5 is selected, we will select 3 and update my counter by 2, and we'll go like this, right? Again here this will not be executed, this part will be executed, but 3 is selected for this edge, so we will not select anyone, we will reach here. For 3 is the child and 1 is the parent, so one of them is selected, right? So we will not select anyone, we will go like this and I will return 2, right? So that's why how our problem is solving the question, our code is solving the question. So if you like the video, and if you like this, then please do like, share and subscribe. See you in the next video.